5 times 5 is?
25.
Yeah. Hey folks, welcome out there. Welcome, and welcome again. All right, we're so glad to have you tuned in this afternoon. Hey, I'm Ernie Roberts. I'm your host for Mathline. That's the show. That's what you're watching. Get ready. Let's have some good fun. Make the show rock. All those good things. We need you to call. And speaking of calling, we've got some great operators today. We'd like to introduce them from Bearden High School Key Club. They are with us. They got to start an hour late this morning, but they're still here. Rhea, Jesse, and Emily. They aren't getting any calls yet, all right? So we need you to pick up those phones. Give them some calls. 844-686-2378. They're giving of their time, service to the community, and service to you all to help us out with the phone management today. And again, we want to hear from you. All right, that number, 844-686-2378. Give us a call. What we'll do, we'll work it out live. What do we work? We'll work out a math problem or two or four, whatever you need, all right? Live on the air together and see what happens from there, all right? But you got to give us a call first, and these guys are ready to take care of you. So speaking of which, do we have a problem? We do. Let's go to problem of the day. Short and sweet one today, it looks like. Change 12 over 25, or 12 25ths, to a decimal and a percent. So basically, this looks like we're going fraction to decimal, and then we're going to fix a percent from that, which really is pretty easy once we get to that point. So let's take a look at what's happening here. Remember what I said to begin with. When we talk about this fraction, which it is, a nice little fraction, 12 out of 25, or 12 over 25, or 12 25ths, lots of different ways we can read that. That is a division also. It's basically telling us that we're going to say 12 divided by 25. Now, you know as well as I do, this is not going to be more than 1, all right? It's not even going to equal 1. So we are going to be looking at the larger number being on the outside when we do the division, and the smaller number hanging out on the inside. And at that point, that's where a lot of people go, well, it won't go. And you're right, 25 won't divide into 12. It will not. No matter how hard you try, it's not going to work. So what we have to do, we put a decimal here, and we're going to add a 0 as needed. Now, how many do we need? We'll find out here in just a second. So basically, now what we're looking at is let's divide 25 into 120. Now, I'm thinking 25 is a nice number. It really is. Because we think of money, right? We think of money. So I think that's like $1.20, all right? That means you would have possibly maybe 4 quarters plus some sort of change going along with it. Because think of that, 25 cents, a quarter, whatever. But when we divide 25 into 120, we know we cannot end up with more than 120 when we multiply whatever number we pick here. So for example, if I pick 5 times 25 is going to nail me at what? 125. So let's think a little bit. How about a 4? Because if we say 4 times 25, you know what's going to happen? We're going to end up with 100, and that keeps us underneath, and plus the fact we get a 20 left over when we subtract, and on top of that, hey, 25 going into 20, yeah, it doesn't work, does it? But that's important because we didn't want it to be bigger than 25, right? So we want to bring down another 0, finish this thing off. Now it's like looking at $2 there, okay? I've got 25. How many quarters am I going to need? I believe that's going to give me what? 8 of those. 8 times 25, that gets us to 200. And we will subtract out. And at this point, we're wondering, what have we got? Well, we have a 48. We have also a decimal that needs to go somewhere. And at this point, the only choice we have is to go straight up, and we'll put it right in there. So it looks like 48 hundredths is what we've got there. Some of you like to call that 0.48, but that decimal does pop up right there. Now remember, 12 out of 25 is pretty close to 1/2, and 48 hundredths is pretty close to 1/2, which would be 50 hundredths. So in regards to what we have here, that's your decimal form. Now, I mentioned we're going to change it to a percent, so let's write this down here just a second. It's really easy to change a decimal to a percent. All we have to do is move that thing 2 decimal places. Why did we do that? Because we're talking with 100, all right? Remember, this is 48 over 100. Percent, when you have percent, you're dividing it by 100. So what we're going to need to do is just change that 2 decimal places, like multiplying through by 100. And folks, there we have it, 48%. So it's really pretty easy. Now, just think about it. If I started with a percent and said, can we go backwards? Certainly we could. We would then shift our decimal back 2 places to the left to get to the decimal, and then write, what, 48 over 100, and reduce it down, and you get back to 12/25. So nice, sweet, little easy problem in many respects. Sometimes we get a little intimidated by the numbers, but I use 25 on that one because I want you to think about money, quarters, something you can relate to, and that makes it work pretty nicely there. But 48 hundredths, that is have a decimal there. Looks like we got, let me put it one more time there. And there's your final total, all right? 48 hundredths, and once again, 48%. Problem of the day taken care of. Now, let's get to our next thing that we need to get going, and that is have some phone calls coming in. We got some folks here from Bearden High School answering phones, 3 of them today. We love it. Trio out there. Get them busy. Get those phones going. That number is 844-686-2378. We want to hear from you. A lot of schools were on delay today, and some were out still, but those are getting fewer and fewer. So we know so many of you are back in school full-time, and you're getting problems right and left to solve math-wise. So give us some calls, all right? We would love to hear from you this afternoon. And again, with them in the studio, you'll have a lot of fun talking to them. And one thing we have been doing here, we got the problem of the day out of the way. Let's talk about problem of the week. So guys, can we bring that one up to refresh memories here? Some of you may be watching us on Facebook and have already seen it in full. This one was kind of lengthy, but that's why it's a problem of the week. We will see it for 3 days, and we'll finally solve it tomorrow afternoon. 3 angles are congruent. The first angle measures, you got 3x minus 4y. X and y they're not really units, but as a whole, 3x minus 4y is the amount of degrees, all right? The second angle measures x minus y, and again, that whole inclusive amount is a degree. And then the third angle measures y minus 10, which would also give us some sort of degree moment here, all right? It says find the values of x and y and the angle measures. So they're the components to make these x and y are the components to make these angles congruent. So let's take a look at what we did yesterday with it. We set up and said, well, we're going to let measure 1, we're going to use measure m of angle 1, that's what that means, the measurement. Here's measure angle 2, we're going to let it be x minus y. Measure of angle 3 is y minus 10. So it's a little bit easier to look at it from there. That's our starting point. And the words congruent made some things pop and happen for us right over here. We have equal measures with 1 and 2. We also have equal measures with 1 and 3 because it says 3 angles are congruent. So all 3 of these are going to match equally to each other. And then also we've got 2 and 3 matching up equal to each other. All right, so the measurements, and measurements. 3 possibilities. Let's do some substitutions here. Our first angle, remember, is 3x minus 4y. And we're going to let that equal to, you got it, x minus y. Just simply substitutions. Just simple substitutions, all right? We'll slide a little line down there, keep that straight. Over here we have the measure angle 1 equaling the measure of angle 3. Now, where does that come from? That's going to give us what? We're back to 3x minus 4y. And this time we're going to have y minus 10. Pretty straightforward. And last but not least out here, we got this 2 and 3 relationship, which might be one of the easier of the pieces here to fit. Let's see, we got x minus y equaling y minus 10. And you say, Ernie, what are we supposed to do with this? Well, I remember when we did systems back in on some of our shows, and when you do systems and x and y equations, you either like to get one of the variables by itself in the situation, or sometimes what's easier is get it into what we call a standard form. All right, so let's go for the standard form. That means we're going to have x and y on the left equaling some sort of a constant on the right. So we have it down to the point where we can get an elimination going, which we will probably finish up tomorrow. I just gave you another clue how to get out of this thing. But let's go ahead and move these things over while we're waiting for some calls, all right? So we're going to subtract the x, we're going to add the y. So we're going to be very careful on this. So that's going to end up giving us what, like 2x. And when we add that y over there, it's going to be minus 3y. Equaling to, it's gone, right? The x minus y equaling to 0. Once again, what did we do? We added the x, we subtracted the x over here, got 2x. We added the y, but that was a negative 4 plus y, which gives us minus 3y. So we're going to leave it at that for right now. Over here, let's take a look at this one. Let's move this y over. That's all we really need to do. And we'll have 3x minus, it looks like, 5y. I believe so. Equaling to, looks like negative 10. So be very careful on that one. Watching our signs, be sure you keep the negative on that 10. It's important. And on top of that one, let's see where we're going here. We are going to have this y. I'm going to bring it over also. Or we could have left x by itself. Sometimes we like to look at that from the standpoint of what am I trying to say here? Getting the x by itself. Substitution could be a possibility. So I'm going to still go ahead and bring it over like we did the others. Let's bring it over in standard form. Subtract the y. So we got x minus 2y equaling, again, negative 10. So those are 3 equations. Now yesterday, what did I say? All we need are 2. All we need are 2 of those. So we're going to leave it with you at that point. Folks, pick any 2 you want. I don't have any really favoritism or preference over the 2 that you've got, all right? So let's go with that. And understand we have a caller waiting for us on the line. Welcome to Mathline this afternoon. Who am I talking with? Namana, how are you doing today?
Good.
Good. Where are you calling from? What city or what county?
Blount County.
Blount County. Okay, glad to hear from you this afternoon. And what can I do for you? What kind of problem have you got for me?
A math problem.
That sounds good.
A word.
You got a word problem?
Yes.
Okay. Go ahead and let me have it then. Tell me what you got.
An international company has 19,400 employees in one country.
Okay, hold on just a second. 19,400, you say, employees, right?
Yes.
I'm just going to write down a few details, all right? And I'm going to spell employees correctly. There we go, all right? In one company, right?
Yes.
Okay, keep going.
If this represents 32.2% of the company's employees, how many employees does it have in total?
Great.
Round your answer to the nearest whole number.
Okay, all right. I just write, good, I did pretty good on that. Didn't get too far off the page. All right, first of all, it's obviously a percent problem, right? Will you go along with me on that?
Yeah.
All right, and what's going on here? I'm gonna use just a proportion because I think it makes a little more sense on this rather than just trying to decide we're going to multiply and divide and do something with it. Let's go back to the setup that we can have a part over what I call the base. Sometimes people will call it a total, but in other words, it's where you started from. Okay, you follow what I'm doing there? Good on
Yeah.
that? Okay, and percent over 100. So in other words, we're taking 2 ratios and we're going to set them equal. We're going to do a proportion. We're going to make a proportion happen here. Now, what do we know? The question is, what do we know? And whatever we don't know, we're just going to call x, n, or some variable. Does that sound good to you?
Yes.
Does that work? Okay. Now, it sounds to me like you're trying to find out where you started from, aren't you?
Yeah.
You're trying to figure out how many people were in the company. Am I good? Am I good on that?
Yeah.
We definitely know we're going to put that percent over 100, so that part we can fix right off the bat. Not so bad, is it? You're halfway there. You're halfway there. So now what we got to decide is, do we have a part or do we have a base? And it sounds like, again, like we were talking about, it says you're told 32.2% of something, but you don't know what it is, do you?
No.
So that's where you're starting from. And that's your x or n, whatever variable you want to put there. What did you end up with? That's the part. That's the part you have at the very end. So here we go. 19,400 goes over x. So far, so good?
Yeah.
Are you handling okay? Now, those are big numbers, aren't they? Those are pretty impressively big numbers. So what we're going to do, we're going to go ahead and cross multiply, and we're going to rely on the calculator to get us through some of this, all right? So the first thing we're going to do, I'm going to take 32 and 2/10, or 32.2, and multiply it times x. So far, so good?
Yeah.
And on the other side of the picture, I'm going to take this 19,400 and I'm going to multiply it times 100. Now, you know what that means? That means I'm going to need to add 2 more zeros to this value over here because there's no decimal. That's a comma, right? So we are going to pull here 19,400 and we're going to multiply it times 100. So you and our viewers will know from whence our number is going to come from, all right? And as I said, we multiply by, how many zeros have I got now? I've got 1, 2, 3, 4 it looks like, right? So let's put that 194 and add 4 zeros to the mix. Do you see where I got that?
Yeah.
Maybe said we got to multiply by 100. Now, if it were something different, we'd go to the calculator on it. But since we got a 100, that's what happens. And by the way, that's actually 1,940,000, which is a lot of stuff, isn't it?
Yeah.
That's not your answer yet, okay? Now, what's the next step? We need to...
Round your answer.
Yeah, let's go find the answer. And what do we need to do with that 32.2 over there? What do you want to do with that? We're hooked in by multiplication, right?
Yeah.
That says times, right? When we say something x. So what do we do to undo that? We're going to divide by 32.2. And what do we have to, if we do it to the left-hand side, where else do we have to do it?
The other side.
Yeah, we've got to hit the right-hand side. So the nice thing about this, they're gone. Those are finished. And you know what? That's pretty nasty looking at that 1 million. Woo, good stuff there. Let's type that in the calculator and let's do a little number on it. Okay, we had 4 zeros, all right? And we're going to divide by 32 and 2/10, or 32.2 as we love to say. And we get, woo, we did get an interesting thing, right? It looks like we had 62,248. And you know what? These are a number of employees, right?
Yep.
All right, so let me put this down here. 6248.4472. I've never seen that amount of an employee. You either have them or you don't, right? So let's go to the nearest employee. And it looks like you're going to be picking that up out of what? 60,248. Does that make sense?
Yes.
Now, let's do something with the calculator again. Let's see that we worked it back through. It should work. But we're going to take that 60,248, and I'm going to change my percent to a decimal, which is a good thing you called, because our problem of the day today, we're dealing with what? Just moving things back and forth, changing from decimal to percent, right? So we're going to make that to move 2 decimal places. So it's going to be 0.322 or 322 thousandths that we're going to multiply by. And I'm hoping it's going to be pretty close to that number we started with, which was what, 19,400? Let's not do that.
Yeah.
I don't know what just happened there. Let me just delete that moment. Let's enter. And we're pretty close, aren't we? I mean, if you round it up, you got it what? You're 19,400, correct? See that? So it checks back through then. It does check back through when we check it out there. So there you have it, and they are your employees. Okay, does that help out? Makes sense? Are we good? I think she may have done. Okay, good. I thought maybe you might have already left the air on us there. Well, thank you for calling in this afternoon. And again, folks, that's how easy it is. So give us a call, 844-686-2378. We've got folks from Bearden High School Key Club here waiting to talk with you and pop you on in here to me, all right? That one has some big numbers in it, but you know what? Calculators, those are what they're good for, all right? Some people say, no, we don't want to use 9 times 9 on the calculator. We want to know those kind of things. But something like that, yes, definitely we would go to a calculator to work through in the real world and otherwise. How about it? Now, let's look at one more little problem. Speaking of real world type things, love these little word problems. And while we're looking at this one, go ahead and give us a call, all right? We'd love to break in the show and have a good moment of rock time here. But 844-686-2378. Like I said, again, take care of, we got Rhea, Jesse, and Emily out there waiting to get your calls today from Bearden High School Key Club. So talk with them and send us a problem, all right? Now, Scott is using here 2/3 cups of fertilizer per shrub in planting. How many cups does he need to plant 9 shrubs? Okay, it's a word problem, but some of you are going like, Ernie, is this going to be more algebra? Absolutely not. Not this time, all right? We're going to do some real just easy thinking prod here, all right? And even the algebra we've done so far today has not been that difficult, except I'll admit the problem of the day has got a lot of stuff going on there, right? But let's talk about it here. 2/3, and he's going to do 2/3 of a cup 9 times, okay, because he's got 9 shrubs to put it on. That's a multiplication. Now, we could write 2/3 down and add it up 9 times, but that would really get it'd be a little difficult, I think. I mean, it was just keeping up with it, and also gets kind of monotonous. There's a much easier way to go with. Let me put it that way. Let's just multiply, because that's what repeated additions are. Let's multiply it by 9. And take a look at this. Basically, we're saying, what's 2/3 of 9, all right? Now, we're not asking how many shrubs in there. We're going to ask how many cups of fertilizer do we have, all right? So let's drop a 1 underneath there, and let's just work good old arithmetic fractions, all right? And again, looking at this thing, we're going to have a nice little cancellation moment. That gives me 3 over there. And I've got 2 times 3. My goodness, how easy did that become? That becomes 6, and we've got 1s underneath. So it looks like here you need 6 cups of fertilizer. Now, go back just a little second here. I threw that together, so to speak, because that's mainly what we would do in our earlier years of working with fractions. But then you get into these years where you do what's called dimensional analysis, all right? So you start off with 2/3 cups. I'll put that there. And you need what? And you're going to do 9 shrubs, okay? And by the way, that's cups per shrub. You say, what? I said it's 2/3. That is a cups per shrub moment, all right? Times our 9 shrubs. And we put it over 1. And see, what's going on there? The shrubs are going to cancel out, okay? So that's what's going on. We're saying 2/3 cup per shrub, or you could say 2 cups for 3 shrubs. Does that make sense? Wow, that would work, wouldn't it? It's going to take 2 cups to do 3 shrubs the way we're doing that. So let's go ahead and look again. It's still going to give us what? 2 times 3, and what's left? You've got 6 cups. So sometimes we can take a problem and do a little bit of understanding why did we come up with cups here. We think about it, oh yes, 2/3 times 9, and that works great. But what's really going on here is you're taking care of the shrubs, say goodbye, because all you're worrying about now is, 9 cups, which by the way, will take care of 9 shrubs. Does it say 6 cups or 9 cups? Anyway, 6 cups will take care of 9 shrubs. Sometimes I get my thought pattern going a little quicker. Now, speaking of quicker, let's get some calls in, all right? We got a couple more minutes here. We'd love to hear from you. 844-686-23 and a 78 on the edge of that. And we love hearing from you. We love it when we have Facebook folks take care of us on Problem of the Day. You can send us questions on Facebook also, by the way. We will answer them best we can. Also, you can send us by email, yes. And you can always, of course, check us out on our live YouTube performances there that are live, or you can call them. You can get them by, what am I going to say here? By streaming. And then also you can go back and check them on using our online approaches, okay? So one real quick thing here. Let's take a look at one more problem while we're waiting for calls, and we'll see what we got here. It says, how many lines can be drawn through pairs of different points A, B, C, and D? Little geometry moment here. Actually, one of those little things that some of you are going like, ooh, I can draw those 4 points on my paper at home. You certainly can, and go for it. Because what we're doing, we're talking about drawing it through pairs, all right? So let's do it. Here's an option, A, B, C, D, something like that. And if I were to take, with these 4 points, I was working at pairs of different points, I would be going through like AD, DC, BC, AB. Oh, someone's asking, could you go across from B to D? I certainly could. And could you go, same thing with A to C. So I think about 6 moves that I've got there. But now someone out there, I know someone out there is thinking this. What if they all line up? I didn't really specify they had to be in this shape, did I? So what happens if we let them line up here? Ooh, 1, 2, 3, 4, A, B, C, D. And guess what? If I draw a line from A to B, it keeps going. These are all collinear points. It picks up C, it picks up D. No matter how I do it, if I've got them all 4 lined up, I have a different answer. It's kind of an open question. There we go. And again, there's 1 there. Another option? How about you got 1 point here and Ooh, 3 points down there that do line up. How many lines could you put through that? That's the other question. So we'll reveal that answer tomorrow because I understand we're getting close on time. And that's kind of one of those questions where you have 3 possibilities. Maybe more? Well, I don't think so. I think we got 3. We'll be finished there. All right. So anyway, thank you for tuning in today. Thanks for our caller from Blount County. We do appreciate you so much calling in today with a good percentage practical problem there. Also, our folks from Bearden High School, Key Club, let's give them one last look. Here we go. Thank you, Rhea, Jesse, and Emily, helping us out today. Been great to have them with us. I understand we got some more Bearden folks that are coming in the few more weeks here. So you won't want to miss out on that, and you also want to call in. All right, get those problems ready. School's back in session for almost everybody. And those of you who are still a little wet out there, hope it dries up soon for you. And you know, folks, we will see you again next time.